Today we will cover how to prepare a tool for composite layup. This instructional video will cover how to properly prepare a plug, splash, or call sheet prior to fiber and resin layup. This is a very important process which ensures that a layup can be correctly removed from the tool surface while maintaining an optimum surface finish. Without tool preparation, parts may be very difficult or impossible to remove from the tool. This is especially a problem for foam tools where prying a part from the mold may cause damage to the tool. By following the steps that we have outlined in this video, you can ensure that any composite parts you make will easily come free from the tool surface. Students that have completed ETech 333 may work in the Composites laboratory. The Composites lab is located on the bottom floor of the engineering building in room 112, located behind the plastics processing lab. This is where all tool preparation procedures should take place. First, we will discuss safety concerns associated with the facility and with tool preparation. Safety glasses and closed-toed shoes must be worn at all times. Be sure to wear gloves when handling hazardous materials. Gloves can be found next to the tool board or near the entrance of the soft tooling lab. Some tools may have sharp edges. Be sure to handle them carefully. The Composites tooling lab is equipped with vents to circulate air and remove fumes from the chemicals used. Ensure that the room you will be working in is well ventilated, as acetone is flammable and a potential carcinogen. All mold preparation processes must be completed on the table clearly labeled as mold release area. Do not apply mold release in the layup area, as this can cause delaminations. There are 7 steps in preparing a tool. First, gather all necessary materials. Second, obtain a tool. Third, scrape off any debris using a brass scraper, being careful not to damage the surface. 4. Wipe the surface clean using acetone on a clean rag. 5. Allow any remaining acetone to flash off. 6. Place masking tape around the exterior edge of the tool to mask the sealing area from the mold release. 7. Apply mold release. These steps will be covered in more detail over the course of this video. Before beginning, gather the necessary materials. Most tools can be found on the tool board. First, collect the tool you wish to use for your layup. For the purpose of this video, we will be using a standard call sheet. These can be found in the Composites lab. If using a plug, make sure that the surface is properly coated and sanded to provide an optimum surface finish. Next, remove any large visible debris from the tooling surface. Debris may be present from the previous layup procedures. For the call sheet, we will be using a brass scraper. Razor blades may also be used. Be sure not to scratch or mar the surface during this process, especially when using a razor blade, as it may adversely affect the surface finish of your part. Next, to remove smaller particulate matter from the tooling surface, wipe down the surface of the tool with acetone. Acetone can be found in the yellow flammable materials cabinet on the side wall of the Composites lab. Make sure to wear gloves while handling acetone, as contact with skin should be avoided. Acetone can easily carry dissolved materials through the skin and into the body. Use a clean rag from the clean rag bin found under the tool board. Apply acetone to the rag. Then wipe the surface to achieve a clean tool. Repeat this process until all particulate matter has been removed. Place any contaminated rags in the used rag bin and allow 5 to 10 minutes for any remaining acetone to flash off before application of mold release. Apply masking tape to the sealing area of your tool. This provides a definite barrier to ensure that mold release is not applied to the sealing area. The final step is to apply mold release to the tooling surface. This can be done in 2 different ways, either wax or PVA. To apply wax, first collect wax from the flammable materials cabinet and a clean rag. Using a screwdriver, pry open the lid of the can. Holding the rag in a gloved hand, scoop a small amount of wax onto the rag and apply evenly to the tool surface. Using a clean portion of the rag, buff away any built-up residue from the surface. Repeat this process 3 to 4 times to ensure a complete coating. An alternative step is to apply polyvinyl alcohol or PVA to the tooling surface. This can be done in combination with wax and will ensure that the part can be easily removed from the tool, but it may also result in brush strokes being left on the surface. First, collect PVA from the flammable materials cabinet as well as a chip brush found below the tool board. Pour a small amount of PVA into the PVA container for use and place the bottle back into the flammable materials cabinet. Dip the tip of the brush into the container and wipe off any excess on the lip. Next, apply an even, thin coat to the surface using unidirectional brush strokes. A even green film will appear on the surface. Make sure to cover the entire tool surface, as any uncovered portion may inhibit proper removal of the layup. Also, make sure that excess mold release does not pool, as it may result in a poor layup surface finish. After a layer of PVA is applied, it must sit to dry for at least half an hour. This drying process can be accelerated using the heater above the layup area. These heaters can be turned on using a dial located on the side wall of the lab. Once the release layer is dry, repeat the application process 1 to 3 more times. Applying more will ensure the layup can be removed properly. However, make sure not to apply too many coats, as this results in pooling and a less desirable surface finish. After all mold release layers are applied, remove the tape from the tool surface. You will then be ready to gather fibers, resin, and bagging materials to proceed with creating a composite layup.